All right, good day everyone. This is Jason Straight with the Past Cloud Virtual Group. Our presentation today is Big Data Analytics in SQL Server 2019 Big Data Cluster using Spark. Our presenter is Niels Berglund, and I'm going to hand things over to him in just a moment. Just got a few announcements I want to cover here. So if I focus on the right screen there. All right, here we go. So our sponsor for this virtual group is Microsoft Azure. They sponsor us because they think that folks should know more about what is available in the cloud, and it seems to be a pretty good pairing with what we present on here most of the time. So if you haven't checked out Microsoft Azure, I really recommend you go and doing so. As far as content goes in this virtual group, you can find out about what's going to be coming up by subscribing to our virtual group at cloud.past.org. And you just log in, subscribe, get to the newsletter, and once you get the newsletter, you will find out about all of the upcoming presentations. Right now on the screen there, I've got, I think, 13 of the most, of the soonest upcoming presentations. We got presentations on AI, we got Power BI, we got some machine learning, SQL Server, SQL database service tiers. So lots of different opportunities to learn coming up here in the future. I think between now and the end of March, we already have 30 sessions scheduled. If you are interested, though, in presenting, we are always looking for more presenters, and you can just reach out to us by filling out the Call for Presenters form that's out on the virtual group. Or alternatively, you can just email me at cloud@past.org. Either way, I'll get you on the schedule, and then we can have you deliver to our virtual group. Coming up actually next week is the virtual PATH Summit 2020. If you have not yet registered, you're running a little bit out of time, and if you need to get a discount on that, we can get you a discount through our virtual group. The virtual group has a discount code that's right there on the screen, and if you miss it, I can type it into the chat for you. Coming up also as part of the PATH Summit is a number of Microsoft focus groups. These are opportunities to learn more about what's coming up from Microsoft directly from them in some focus groups where you can also provide some input that will impact the path of those features. So to get to those, just go to path.org, and then go to the Summit 2020 Learn Microsoft Summit link, and that will get you to registration for those focus groups. This virtual group is part of a number of virtual groups that PATH helps to put together. They focus on different areas of technology like application development and data architecture. And in some cases, they focus on languages and culture to help folks bridge and learn more in some of their native tongues, such as Global Hebrew and Global Italian. Throughout the session, I think some of you will probably have some questions. It's a fairly common experience for folks. And if you do, please type them into the GoToWebinar interface. And then as time goes through, we get to the end of the session, we will go through those questions. And with that, those are all of our announcements today. And so our presentation is Big Data Analytics in SQL Server 2019 Big Data Cluster using Spark. And at this point, I will hand things over to Nina.
Thank you, Jason.
Yeah, almost there. Now your presenter.
Awesome. So once again, thanks, Jason. I hope that you guys are seeing a intro slide in a slide deck saying Big Data Analytics with SQL Server 2019 BDC and Apache Spark. If you're not, then we have a problem. I mean, one of the most asked questions at these COVID times must be, are you seeing my screen? Can you see my screen? So I will not ask you that. I assume you can. So welcome, everybody. And once again, thanks, Jason, for inviting me to this. We are in this session, we're going to talk about SQL Server 2019 Big Data Cluster. We're going to talk about big data. We'll talk about analytics and using Spark for analytics. I'm Niels Berglund. I work now out of sunny Durban, South Africa. Right now, this evening, it's here in my part of the world, it is 8 p.m. And we are going into summer. So I just told Jason before we started this that Durban is on the is on the Indian Ocean side of South Africa, and if it gets below 20 Celsius here, then we find it very, very cold. However, I'm from Sweden originally, so yeah, I'm used to cold weather. Anyway, that's enough. So yes, software architect at a company called Rivco. I've written a book. I'm an data platform MVP, been doing teaching, instructing, I'm speaking, and I am a long time user of SQL Server. Long time user of SQL Server. And I work closely with Microsoft around SQL Server, especially Big Data Cluster, and also a thing called external languages, and I'll touch a little bit upon that at the very end of this presentation. So without further ado, let's get into it. Before we look at the SQL Server part, let's talk data, because SQL Server is not the important part here. Apache Spark is not the important part here. What is important is data, because if we didn't have data, we wouldn't need SQL Server, we wouldn't need Apache Spark, we wouldn't need analytics. And having data, it is of the utmost importance that we are doing analytics, because if we do not do analytics or getting insights into our data, then our competitors will, and they will eat our lunch essentially. So using data, using it the smart way, getting insights into data is vital, and it gets more and more vital as time goes on. And the outline of the data landscape is that we are getting more and more data. And there has been some investigation, some research, and people are saying that in 2016, we had around 16.1 zettabytes worth of data, and worldwide, and a zettabyte is a billion petabytes, so it's a lot of data. But it doesn't stop there, because we are also saying that, so these are investigations by the likes of Gartner, etc. So it has some relevance at least. But they are also saying that by 2025, this amount of data will have tenfolded. So gone from 16 zettabytes to 160 zettabytes. And that's a lot of data. And the question then arises, right? That what do we do with all this data? Because the data is stored all over the place. How do we manage this data? What do we do with it? Because having data for data's sake is not really useful, right? We need to do something with it. So from a Microsoft perspective, they see SQL Server as an excellent thing here to bring in to get intelligence over your data. And if we think about SQL Server, right? SQL Server has evolved throughout the year. So I'm an old guy, actually quite old. So I remember when SQL Server was in version 4.2, they shared code base with Sybase, and it was, to be honest, fairly useless. SQL Server at that stage. Then SQL 6.0 came, SQL 6.5, and at SQL 7 things started getting interesting. And that's when Microsoft split from Sybase with code sharing, and SQL Server essentially got its own code base. And if we think about SQL Server and how it has evolved from initially being a pure relational database engine, Microsoft added integration services to be able to do ETL and stuff like that. They added analysis services to be able to data warehousing and analysis. SQL Server 2005 was for me a huge release, because Microsoft introduced, among other things, SQL CLR, i.e. the ability to run .NET assemblies inside SQL Server, and God knows that I have used and abused that throughout the years. So SQL Server has evolved. We in 2005 we also got the support for XML. 2016, I think it was, we got support for JSON. So there has been a constant evolution of SQL Server to get into a place where we should be able to manage all our data, to be able to integrate all data wherever that data is, right? We may have data in God forbid, in Oracle somewhere. We want to integrate that with SQL Server. Right? And then, as I said in the beginning, we want to analyze all this data, because if we don't analyze the data, we are not getting any benefits of the data, we are not getting any competitive edges, and we are like the doo-doo, we're kind of dead. Yeah. So, and this is now then where, so you may say that, hey Niels, this sounds all good, but hey, SQL Server, I mean, SQL Server is the SQL Server. How can that help me? How can that help me manage all data, integrate data, analyze all data? Well, in SQL Server 2019, introduces something called the SQL Server Big Data cluster, which is a completely different beast than your, let's call it your normal SQL Server. So it's the SQL Server 2019 Big Data Cluster, the BDC, is there so we can extend SQL to store data in the petabyte range. Well, we're not in the zettabyte range, but we're in the petabyte range at all. So, and that is also a lot of data. We want to be able to store any kind of data. Right? Not only relational data, but any kind of data. And then subsequently, we want to be able to analyze all that data, relational as well as non-relational. And what the big thing here with SQL Server 2019 Big Data Cluster is that this is now SQL running in Linux containers on Kubernetes. Think about that for a second or two. Microsoft all of a sudden loves Linux. Microsoft all of a sudden loves open source. And God, how things have changed since back in the day when Stephen Ballmer stood up at a conference and said that open source was like a cancer, Linux was a cancer. Anyway, so the big data cluster is not your normal SQL Server SKU. It is completely different. You install it on Kubernetes and you run it from Linux containers. Right. The part of this now SQL Server Big Data Cluster is, so okay, let me take one step back. I said that we should be able to handle all types of data, not only relational data. And the de facto standard for storing, well, almost de facto standard for storing non-relational data is Hadoop. And the de facto standard for analyzing this kind of data has moved more and more towards Spark, Apache Spark. So as part of a SQL Server 2019 Big Data Cluster is Spark, the Spark compute engine, and it's also the Hadoop file system. So when you install your 2019 Big Data Cluster, you out of the box get, well, not only SQL Server, obviously, but you also get Hadoop and you get Apache Spark, plus a lot of other open source things such as Elasticsearch, InfluxDB, Grafana, Kibana, all that good stuff. But so for this particular presentation now, we are kind of interested in the Spark compute engine. So when we are installing a SQL Server Big Data Cluster, we're getting Spark together with SQL Server above, sitting on top of Hadoop file system data nodes in a Kubernetes pod, right? So what is Apache Spark then? Well, it's a distributed compute engine. And before Apache Spark, if we were dealing with big data, we probably used Hadoop, or rather we had our data stored in the Hadoop file system. And then when we wanted to analyze this data in Hadoop file system, we used MapReduce. Right? And that was more or less single-threaded. It kind of ran sequentially. With Apache Spark, the whole compute here is, as it is on the slide, is distributed. So I can have my workload, and it will be distributed across multiple worker nodes. And Spark also has that, regardless of what type of workload you have, if you have batch, streaming, analytics, artificial intelligence, etc., Spark has support for that. So you can do Spark in a batch fashion, you can do Spark in a streaming fashion. Spark has an awesome machine learning libraries built in, etc., etc. And as I said, this is not MapReduce anymore, but this is now in-memory data sharing across jobs, across nodes. The other cool thing with Spark is that it doesn't care about storage. Well, it cares about storage, but you have quite a few different storage mechanisms, or Spark can talk to quite a few underlying stores, such as S3 buckets, Hadoop file system, as we mentioned, databases, as we will see, blob stores, what have you. And then another cool thing with Spark is that you have support for multiple languages. So you can run Spark and use SQL for your workloads, Python for your workloads, R, Scala, Java, and recently Microsoft has actually announced .NET for Spark. So choose your poison and use that when you're dealing with Spark. So why would we then be using Spark? What are the scenarios here? Well, if we're having data lake and we want to do analytics, then Spark is an excellent choice, right? We're having high volumes, we're having a variety of data, we have a variety of velocity of data, in other words, streaming, batch, etc. We can Spark allows us to do data analytics. We can take my data, transform it. We can build machine learning models, deploy them, and then when we have deployed my machine learning models, we can do real-time analytics of my data. So I am not limited to do purely batch jobs with Spark, right? So I can get real-time analytics. I can have streaming data coming in that I can in near real-time process and get insights from, which is very, very cool, right? So let's have a look at Spark in a big data cluster. So if I can find my Azure Data Studio. So I'm using, you will see here that I'm using Azure Data Studio because Azure Data Studio has well, let me say this. I was a big user of SQL Server Management Studio, and I thought that never will I go over to this new hip thing called Azure Data Studio. But the more I've used it, the better I like it, and I realized that I can do quite a few cool things with Azure Data Studio. So here we have now in Azure Data Studio, I have Jupyter notebooks, and that is, I guess, a topic for another presentation. But so what I want to do here is that I am in my big data cluster, which I call S2K19-BDC2. And I have here some Spark code, or I'm running PySpark. If we see up here somewhere. So when we're talking notebooks, we're talking about kernels and what kernels a notebook can use. And Azure Data Studio and the notebooks in Azure Data Studio can actually use quite a few different kernels. And in this case, it is PySpark. But if we are looking at it, we can see that we have SQL, PySpark, Spark, Spark Scala, Spark R, Python, and PowerShell, right? So I have here some PySpark code where I'm starting to do a print hello world. I'm importing some Python libraries, and then I'm essentially running some Python code where I'm doing squared numbers. So let's run that. And yeah, that was not good. Session not found. I wonder what that is. Let's see if we can fix that. So this is the demo devil, right? When, hello. Now we have a problem. Let's see here if we can do something. We're running there. All right, we'll come back to this. So I was supposed to do some Spark code here. It seems that we have an issue right now. Let's see if we can fix that. Anyway, let's go back to the code here let's go back to the slides here for a while, and let's come back to the code. So big data cluster. So as I said before, the big data cluster runs on Kubernetes. So the architecture looks somewhat like what we have here on the screen, where if you know Kubernetes, you know that as part of Kubernetes is a control plane, and then you have your pods, your containers, etc. over here. And I will not touch upon the control plane at all here. I just wanted to make sure that you sort of get an insight that we have something called a control plane, but for this kind of discussion, it doesn't really matter. So the important part here is here on the right-hand side, right? The actual big data cluster part, where when I now deploy my SQL Server 2019 big data cluster, I get my SQL Server master instance. So this is not the master DB, but this is that instance that you normally deploy through an ISO or installing an ISO or such alike. So that's the master instance. This is what you are talking to. This is where you are querying against. This is where you have databases, etc., etc. Then we have pools. Well, what we call pools. We have a compute pool, we have a data pool, and we have a storage pool, and then finally we have something called an app pool. And I will not touch upon that in this presentation, but we will look at especially the data pool and the storage pool. That's kind of what we are using for our big data needs, right? And then the master instance over here is the entry point into the data pool and the storage pool. But as I said, we'll look at this more in detail in a little bit. So integrate and manage data. How do we do that? Right? We essentially have two ways to do data integration. We can do data movement on the left-hand side, or we can do data virtualization on the right-hand side, or we can do a mix of those two, right? So data movement, that's your typical old-time, well, your ETL, your ELT, where you have data sitting in a source, and you move it over to somewhere, right? And that somewhere is then where you are querying the data from. So we have data in the source, we move it to some other place, and we're querying it. Yeah, I mean, that is doable. It is working. It has its drawbacks in case that we are actually duplicating data, we are moving potentially large volumes of data across the network. And I don't know about you guys, but where I work, the security department is a little bit sort of skeptical to moving data over the network to expose data to various places, right? And that's then where data virtualization comes in, where we still have the data stored in the source, but we are, instead of moving the data to here, we are virtually representing the data instead in this database. And when we are querying against this database, this data, the query is being pushed down to the actual source. So that is data virtualization. And if we're looking at SQL Server and the history of data virtualization, well, back in the day, we had linked servers, and I have a sad face there because, yeah, they probably, at least back in the day, they were not that good. Had very limited support for various data types, etc., etc. To be fair, that has kind of been improved a little bit lately, but still, yeah, linked servers may not be the best thing in the world for data virtualization. Something called PolyBase was introduced in a product called the Analytics Platform System, which eventually turned into the analysis services. And PolyBase allows you to talk to other data sources, and they work through something called external tables, where you create an external table in your database, and that external table represents a remote data source. So PolyBase, as I said, first was in something called the Analytics Platform System. It eventually shipped in SQL Server 2016 as a core part of SQL Server 2016. Then the SQL Data Warehouse throughout these years added more features to PolyBase, and SQL 2019 ships with a very, very enhanced PolyBase, which we will have a look at in a second. So if we look at SQL Server 2019 as a data integration hub, it looks kind of like this, that you have here, right? You have here your master instance in your SQL Server Big Data cluster. And with that master instance, you are using T-SQL, as we all know and love, to talk to the master instance. And then we can now, through these PolyBase external tables, to call down into big data, Cloudera, Hortonworks, Hadoop. And SQL Server 2016 also allowed us to talk to Azure Blob Storage. But yeah, sure, for big data, this is cool. But if I have data stored in many different places, will this actually give me anything? So in 2019, SQL Server 2019, Microsoft enhanced PolyBase so that we also can talk to relational databases, Teradata, Microsoft SQL Server, and GASP, Oracle. We can talk to NoSQL, MongoDB, and Cosmos DB, and that is not all of it. We can also talk to any ODBC data sources. So if you have data in an Excel spreadsheet, you can essentially, by using ODBC, call that from inside SQL Server. So anything that you have an ODBC driver against can now be exposed as a PolyBase external table. And then finally, we are getting now through this compute pool that I briefly mentioned that we will have a look at in a second, we are getting a scale out in order to improve performance. So let's have a look at code and see if the demo gods are with us. So what we're going to do here is that I have somewhere, let me see if I can find that. Yeah, I have here, and so I'm running. I'm running my big data cluster in Azure in the cloud, and also up in Azure I have an Oracle database somewhere. And if you ever have used Oracle, you know that you have the table, something called a schema called Scott, and a database, a table called EMP, and that is a little bit like AdventureWorks or Northwind back in the SQL Server days. So if I execute here, I will eventually get saying something that I need to connect, I hope. Come on. Or not. This is not really with me today at all. There we go. My connection has been reset. Let's run that, and we will, as you see here down at the bottom, I'm now getting the results back from doing a select from this table. Right, so what I want to do here, I want to create a new database that we called Niels Database 2. We run that, and we're saying use Niels Database 2, and we're selecting my database name just to make sure that I am in the right database. And so I want to create now an external table against my Oracle database. And since in Oracle, I need to authenticate, so I need to create here a credential, and that credential has to be encrypted by a symmetric key. And as this is now a brand new database, I shouldn't have any symmetric keys here. So what I'm doing, I am creating a master key on a database level. Cool. And now I can create my Oracle credential that I will call Oracle Cred with my username and a password. Yeah. So let's create that. Cool. And when we're selecting from database credentials, we can see that I have Oracle Cred here. That is cool. And now I can create an external data source. So when I have an external table, I also need an external data source. And this external data source points to my data source, in this case, Oracle, to my Oracle server. So I'm creating an external data source that I call Oracle connection. I'm saying that it's Oracle, and I'm giving it an IP address, and then the actual credential that I created above. Cool. Having done that, I am now ready to create my external table. So I'm calling it DBO emp _ aura. I'm ensuring that my columns are the one that I have in that particular table. I'm saying the service, the table schema, and the table name, and what the data source is. And when I run that, I have created it, and now I can do a select against this external table. And now we're getting back the same data as we saw before when I queried Oracle directly, right? So I have now queried an external table, select star from, gotten a result back, but the result does not sit in SQL Server, but it sits still in Oracle. So when I'm doing a space used on my table, here, we can see that there is null rows, null data, no indexes or anything like that. Yeah. So the data still sits in Oracle. You have not moved any data whatsoever, but you have queried it exactly as you would have queried SQL Server. And this is now, so if you now want to do analytics, right, you don't necessarily want to move your data to where your SQL Server is, but you can query it with external tables. Cool. Let's go back to the slideshow. So the integration hub we have seen here. So going back to the architecture diagram, and now we will look at these three pools here. We'll look at the compute pool, the storage pool, and the data pool, because that's especially the storage pool and the data pool are the two interesting parts here. So a compute pool, that is, well, it's SQL Server instances that is a resource boundary, so data and security boundary. It processes complex distributed queries, and the compute pool consists of SQL Server engine instances. And we are using, or SQL Server, the master that we saw is using the compute pool to be able to scale out queries over multiple instances to get better performance if we are running very compute intensive queries. So we have in SQL Server 2019, or in the SQL Server 2019 Big Data cluster, we have a scale-out query engine. And this scale-out query engine can now distribute your queries against across multiple compute pool instances. And this doesn't happen every time. This is a little bit based upon what the data source properties are, etc., etc., etc. Right. So that is one way to improve performance. And when we are looking at an example, we have the user over here executing a query against the SQL Server master instance. The scale-out query engine sees that this query requires, could benefit from scale-out. So let's ship it to the compute pool, where the compute pool SQL Server instances are now querying against the ultimate data sources, whether it's a relational database, whether it is Hadoop, whether it is some other NoSQL data source. Right. Cool. The storage pool, so that's the compute pool. I don't really have anything more about it, but now we're coming into the interesting parts here. So the storage pool, this is the place where we now have your Hadoop, the Hadoop file system. So a storage pool node contains Spark, it contains SQL Server, and it contains an Hadoop file system node. And we are storing the data in the Hadoop file system. So you can ingest data into your storage pool into a Hadoop file system, and you can query the data. We can also, so as Hadoop file system now comes part of the big data cluster, we can, in addition, mount remote HDFS stores against the storage pool, a little bit like you see down here at the bottom here, how we're having other HDFS stores and remote cloud stores that is now mounted against an HDFS data node. Right? That's called tiering in the BDC world. The way we can ingest data into HDFS is we can do it through SQL, or we can do it through Spark. And the way we are accessing data is HDFS and or SQL endpoints. So all this in big data cluster, the common denominator between all this is that we still have T-SQL as we know and love, which we can use to query whatever data store we have. And by having a storage pool, we can create a data lake. Yeah. So let's go and have a look at that. So I have here an I call it Niels database 2, right? I hope. So let's run that. And let's select database name, and we're in Niels database 2. Cool. When I look here at my big data cluster, I can see, I mean, from Management Studio, we are used to seeing databases, and I'm not seeing my Niels database 2, which I do now. We can see databases, security, server objects, but notice here, we have something called HDFS. So in HDFS, well, that is our Hadoop file system, and we can now store data in here. And when I installed my big data cluster, I also ensured that I have some data here stored in HDFS. And if we're looking here, we have something called clickstream data. So I have uploaded a CSV file with clickstream data, and we can preview that. This will take a little bit. We have truncated the file to 30 meg. And here we now have some clickstream data. And we will have a look at what these values mean in a second. But this is now data stored in Hadoop file system, right? So let's click that. We don't want to save it. And what I want to do now is I want to be able to query this data through T-SQL. I don't want to use Hive or Pig or whatever it is called. I want to use T-SQL. So what I do is, so as I did with Oracle, I'm creating an external data source. We are not authenticating, we are not logging into this, so I don't need a credential. So I'm creating an external data source where I'm saying that, okay, so this is SQL HDFS, SQL Hadoop file system, and so which is the location. So we run that. We have created that now. As this is non-relational data, we need to define the file format. And this is now a CSV file. So I'm creating an external file format, which I call CSV file because I have no imagination. And it is delimited text. The field terminator is comma, string delimiter is double quote, and we are using type defaults. So we run that. We have created my external file system. If we're selecting against it, we can see that I now in my Niels database, I have a CSV file system, which is delimited text. Right. So now I want to create an external table. So I want to create a table that I call web clickstreams HDFS CSV, because that will tell me exactly what it is. So I'm saying create external table. I have a click date, which is a big int. I have a click time, which is a big int. I have sales queue. So a lot of big ints here, but that's the way it is. The data source is the one that we created above, and the location is now from the root of the HDFS directory. So that is now clickstream data. If I had multiple files, CSV files, all of them with this, by doing it this way, all of those would have been included here now for my external table. So let's run that. Commands completed successfully. Cool. And now let's do this, select a top 10. And here we now have the 10 first rows from my external table, which really is not the table per se, but it exposes the data here in my web clickstreams CSV file. And I can do queries against this and whatever you have, right? And as with if I were to do a space used on this table here, it would be exactly like it was for my Oracle table. No data is stored in my clickstreams table. The data still sits in my underlying store here, the HDFS store. And I find this very, very cool that I can now query HDFS data by using T-SQL that I know how to use, right? So that's the data pool. This is now where we are keeping our big data. The data pool then, right? Let's go back to here and I'll show you something. Data pool. So let me use my original database because I think I have potentially. So I have a query here now, right, where I am querying my external table, the clickstreams HDFS CSV table. I am joining that against an T-SQL, a relational table in a database called sales that I have here. And I joining it on some criteria and I'm doing a group by, and I have done some aggregations and stuff here. When I run this will take a little while. So sometimes you do not want, sometimes you want to create something like a data mart where you are aggregating data together and you put it into a relational table because you will get better query performance, because querying an external table is not as performant as querying a real table, so to speak. And when we see here now, so this query that I executed, that took 24 seconds. So what we can do to make this better performant is to load data into a data pool. And the data pool is a scale-out data pool. It has instances of the SQL Server query, the SQL Server engine, the persistence store in SQL Server, and it is sharded, so you can shard out your data in the data pool. So in essence, the data is now distributed into different shards, and by doing this, I can now create like data marts, scale out data marts. I can have what feeds into these shards can be Hadoop file system, it can be Cosmos DB, it can be SQL Server, it can be Oracle, it can be anything that I have a PolyBase connector for. Yeah. And for example, if you have a machine learning or data scientist in your organization, they may not want to query against the, well, let's call it the real data sitting in an external data source when they are building their models, because that will take a little while. So what we are doing is we are loading in a couple of million records into this data pool, and they are working against that data pool just to create the models, and then against the real data when we are doing the evaluation of the model and when we are scoring, etc., etc. So, right. So let's do this. So we go back here to Niels database 2. Come on, Niels database 2. We have already seen the long-running query, so we won't do that. So now what I want to do here is I am creating a new external data source that I called SQL data pool, strangely enough, and I'm giving a location for the SQL data pool, which is that. We create that. And we have creating the data source. We are creating now here an external table that we call the WebStream clicks data pool. And when we are creating the table, we are saying, well, the data source as before, and we are also telling how the data should be distributed. And in this case, I'm now saying that I'm just doing a round robin. I don't really care. I can, if I want to, have my own algorithm here for distribution, but for now, round robin is fine. Let's now ingest into the data pool. So this will run for a while, and let it run. And when we are doing the ingestion, all right, so here I'm using T-SQL. I can also use Spark for this. And if we will, in a second, go and have a look at Spark and see how we can do ingestion. And I really, really hope that it will work. So here we have now inserted 585,000 odd rows into this data pool. Let's select the top 10. There we go. Cool. We have some data in there. And now when we're running the same query as we did before, more or less, but instead of using the HDFS external table, we are now using the data pool aggregated table. Let's run that. And that took now, so before, when we didn't have the data pool, we executed in 20 odd seconds, whatever it was. Now we are down executing at 5. So we now have a scaled out data mart here. When I'm looking at my tables now, what does my data pool look like? So I can do an execute at, where at is now I'm defining my data source. So let's use Niels database 2 for executing. And notice now here how we have how we have 2 tables in my data pool, right? Because my data pool is sharded out. And when I'm looking at space used against my data pool table, so remember for the storage pool and the Oracle, my table was empty. But when I run this against my against my data pool table, we will see here how I have 293 and 292,000 rows in these two instances because the data has been sharded out against my two instances. And that's the beauty with the data pool, that you are getting automatic sharding. You as a developer, as a user, you don't really care. You just ingesting as you always do. And if you're querying the data, you're querying as you always do, but under the covers, some magic happens, data is being sharded, etc., etc. Cool. So let's have a look at how we can ingest data here. So when we are using Spark, right, we have an SQL Server Spark connector, so that Spark can connect to SQL Server, can connect to data pools, and it can connect to HDFS data nodes, right? And what we want to do is we want to take here, I have CSV file here called adult census income. So it's a census investigation from a couple of years back, which has quite a lot of data in it. And that is now stored as CSV in my Hadoop file system. And I now want to use this in Spark. So let's read it in. Okay, so I have an issue here with Spark. So guys, I'm really terribly sorry. It seems that my Spark has decided that it don't want to play anymore. So let's just look through here and see what would happen is that I would read in this data into a Spark data frame. I would do some, I would connect using Spark. I would then say that read in my data from this adult census income and write it out to a table that I called adult census test, right? So we are defining the server, the database, the user to use, and then we're saying data frame write, and we are using the Spark connector. We are using an overwrite mode. We are setting the URL to where we want to, the database we want to hit, what table it is, etc., etc. And then we are calling save, and that will now write to this table, right? So if I if I change the kernel here to SQL, and we're saying use news database, and we're saying select top 10. And we have now from the adult census CSV, we have ingested that into a normal T-SQL table, right? We can do the same thing by writing to the data pool, where we are reading in, and then we're saying that we're having a data source for the data pool. We're saying that we're creating a data pool table, user password, data pool, data source, and we are writing to that particular table in the data pool, and that is called adult census data pool table. Let's see, where were I? Let's see if that works. And here I have now read it in from the data pool table, not the SQL table, but the data pool table, who at this case is now sharded. And we are running out of time. I am sorry for having problem with the with Spark. but we can also then use Spark and machine learning, where we have some data. I am splitting the data into training set and a test set. We are doing some training, we're doing some scoring, and we're getting a model. And we can now persist this as a Spark model and or as what we call a portable model, which we then can use to score against. And just quickly here, we would read in adult census. I would do some basic data exploration, saying what columns I'm interested in, etc., etc. I would find out what are the labels, what are the features that I'm interested in. Then I would split my data between training and testing. I would save it into HDFS as adult census income train, adult census income test. And then I would use this to do some logistic regression. And eventually, when I've created this logistic regression model, I can now predict against it. And I'm getting here, and if you're into machine learning, you have area under the curve and etc., etc. And these two values indicates how good or bad my model is. And then I am persisting this model into the data, into my into HDFS, and I can subsequently read it back out and predict against the model. The final thing here is that with Spark, you can create a portable model where machine learning is essentially just mathematics, and based upon your logistic regression model, you can now create a portable model where we're calling it an MLeap bundle, and this can now be exported to other databases. So where you don't need your Spark model, you have your MLeap bundle, and you are using the MLeap bundle to do the prediction. To do that, however, you need to use Java as a language to do the prediction. And in SQL Server 2019, we have the ability to use Java through the Java language extension, where we are executing something called sp execute external script. We are sending what language is it? It's Java, and we're sending in a package, class name, method name, and some input data, etc., etc. And we are getting back a result set. If you're interested in external languages, have a look at my blog. I have written quite a lot about external languages and the Java integration, R integration, and Python integration, etc. And I believe we are out of time. So, and I once again apologize for my Spark not working. I was going to say it worked on my machine. Well, obviously it didn't. It worked an hour earlier, but it didn't now. So anyway. So summary, our data volumes are increasing by the second. We have data, not only relational data, but all types and shapes. And we need a way to handle this data, and we do that through the big data cluster, which runs on Kubernetes. And part of Kubernetes is Apache Spark and Hadoop file system. So, and that gives us now the ability to query data, to analyze data, regardless of what data it is. If it is relational data, if it is Hadoop data, if it is NoSQL data, we can use SQL Server 2019 Big Data Cluster for analysis together with Apache Spark and Hadoop file system. And that's that. Thank you, guys. Questions?
Yeah, we've got a few questions here. We've probably got a couple minutes to cover these. So the first one is do you think PolyBase is potentially too much if you've got a large number of tables, say like 300 tables that you're bringing in?
Honestly, yeah, I think so. So I would, at the moment, yeah, I would potentially look at something else if you have lots and lots and lots of tables. And to be honest, so the PolyBase as we have now in SQL 2019, that is, well, essentially version 1 of PolyBase for everything but Hadoop. And there are right now performance, not the issues, but the performance could be better. So I would strongly suggest have a look at PolyBase, see how you can use it, if you can use it, but do not expect to get awesome performance from day one. It will get better.
All right. And then can you leverage PolyBase for just data movement, like if we want to extract the data from various sources to SQL Server Data Warehouse 2019?
Yeah, that you can definitely do. But if you want to move data from a source to a data warehouse, for example, I would probably look more at using Spark for that than PolyBase. But yes, you can definitely use PolyBase for that as well. Absolutely. So that is how I have done some of my, when I have uploaded databases, etc., to my big data cluster or moved data, I have used PolyBase for that.
All right. And then I think we've got time for one or two more. Do you recommend to populate analysis service tabular engine from PolyBase tables as well?
Could you repeat that, please? I didn't catch that.
Sure. Do you recommend populating analysis services tabular engine from PolyBase as well?
Ooh, putting my neck on the line here. Right? I would definitely look into it. I can't say a definitive yeah or nay, but I would definitely, it is an option, and I would look into it and see, well, performance, how complex, etc. it is. But yes, I would look into it.
All right. And then the last one we have is it possible to run the solution outside of Kubernetes and Linux?
Okay, so the most popular answer in any computing related questions ever, it depends. It depends with what you mean with the solution. Can you run big data cluster outside of Linux and Kubernetes? No, you can't. So big data cluster is in itself a SQL Server SKU, which requires Linux and Kubernetes. So big data cluster you cannot run outside of Linux and Kubernetes. Can you run PolyBase? Absolutely, absolutely. I mean, PolyBase is part. It's part of big data cluster, but it's also part of SQL Server 2019. So I have a demo or two where I'm using PolyBase from my local 2019 instance, i.e. your bog standard, the SQL Server we know and love, to a SQL Server 2016 instance. And I'm also using PolyBase from my SQL 2019 instance to that Oracle instance that you saw up in the cloud. So that you can, for that you do not need big data cluster. But if you want to use Hadoop file system, if you want to use Spark, then big data cluster is your friend.
All right. And that is all the questions we have here for today. So Niels, thank you for presenting today, and thank you everyone for attending.
Cool. Thank you so much, guys. It's been a pleasure.
All right.
And I hope I'll see you soon again. Actually, I think I'm doing something in the beginning of next year. We're talking Databricks, I believe.
I believe so as well. Yep.
Awesome. I'll make sure that my demos work. I'm sorry, guys, about that. But anyway, cool, guys. Thank you so much.
An hour ahead, check it at 30 minutes.
Cheers. Bye.
Yeah, bye.